Okay guys, welcome back to the channel. This is the second part of the vertical farming alternative systems series, and in this episode I'm gonna make a proposal how you could design an experiment in order to compare whether a alternative system including movement is superior over a normal system, and you will learn more about that in a minute. And I would like to start again with that picture here from the Dyson system that we have already seen in the first series. You can see that we have in a tube, we have 1, 2, 3, 4, 5, 6, 7, 10 times 2. We have 20 modules here, and we have a lot of LED lights. And what I would like to show you by the example of that system is that when we build an alternative system compared to a normal, regular, conventional vertical farming shelf-like system, it simply means that rearrangement of the plants in our space, it also means by the same time that we redistribute the light. In that case here especially, we permanently redistributing the light, the LED lights plus the sunlight. So what you can see here is I have taken that picture from the Dyson website, and I've cut out um, 10 modules. One is on top and one is at the bottom, and this is supposed to be a conventional shelf-like standard vertical farming system with two layers, you know. Um, This here is the first layer, and that one is the second layer. We're using the exact same resources. So at top, the top layer with 10 modules, we only use the sunlight, and at the bottom layer, we are using only the LED lights. Imagine that I have taken all LED lights, also the ones from top, and that they are now at the bottom. So we are talking about the exact same resources, and what I've done is basically I have rearranged the plants in the same space. So I have seen that we had a tube system, and I turned it into a conventional system just by rearranging the plants, and of course we have now redistributed the light. Of course, that light here on top, it is not constant because we have only sunlight, and here at the bottom we have constant light because we have LED lights. And my point is, so you have just seen that no matter from what perspective we start, that we can rearrange the plants in space, and at the same time we redistribute the light on our overall, on our total canopy. So, and my question is now, why should we build a tube-like system? Why? For what reason do we need to arrange the plants in space in a tube? Why do we have a higher efficiency of the system? We're using the exact same resources. This is supposed to be the exact same space that we use for the tubes. Maybe it is even maybe we could achieve the same in a smaller space. Maybe not. I don't know, but that doesn't matter. I'm searching for a reason to build a tube because normally you need an excuse for everything, and in that case, in my opinion, there is no general reason that we rearrange the plants in space in whatever, a column, a tube, or whatever that is. Okay, I think you remember that slide from the first part. So there is something I would like to add, because I have been talking in a very negative way of that alternative systems, and it sounds a little bit like I think it's completely dumb to rearrange the plants in space to build these systems and so on. But it's, in my opinion, it is not a dumb scientific question whether rotating off plants, putting them in alternative positions, and circulating them in columns or whatever type of system you have where they are in an alternative arrangement in our space, and when they move, um, that's not stupid. That's not stupid. Stupid would be like um, we put a can of ravioli right next to a plant and see if it grows faster. That is completely stupid and completely nonsense. Because look, when you rotate plants, when you move plants, it could have an effect on plants. Because this is, for example, a current topic in vertical farming research, and I'm going to cover that in a moment in my proposal for an experiment. And the second part is when you move either the light or the plants, it's possible that you create a situation here you have 100% intensity, and for a very brief moment you have here when a plant is here at that position, you have, I don't know, 75% intensity compared to that moment. And maybe for some plant physiological reason, the um, photosynthetic efficiency could be the same. For whatever reason, it could be the same. It's possible that you create the same situation like with pulse light, where you, in a very high um, with very short interruptions, the light is on and off, on and off, on and off, on and off. And the point is, when you move the plants in the system, I mean, just the general, rearrangement of the plants without moving the plants or the lights, like for example, these column systems, um, I don't believe that there is an advantage. I don't believe that. Um, but when you move the plants, scientists scientists ask the question: is there something else that we that we don't know when we move them, that they grow faster? And that's the point. So don't get me wrong, it's not stupid to do research on that, but in my opinion, or what I assume, is that there is a relative low chance that you find evidence that you get a higher efficiency, a higher energy efficiency when you have like 1 cubic meter and you have, and here it comes, and you have some system where the plants are rotating, circulating, whatever, that you have a higher efficiency in kilogram per cubic meters per units of energy. That this is better than a system that is simply like a standard vertical farming shelf, because that you need to compensate the energy that you require for any type of movement. You need to compensate that with that yield gain that you achieve here, because let's say you have plus 10% yield, okay, but you need 20% more energy. With 20% more energy, you could build another layer, okay? So in that case, what I've just shown here, it is possible that you have a higher yield, but you have a lower efficiency. You have a higher yield per cubic meter, but you have a lower efficiency. So if the energy matters, it's not good. If the energy doesn't matter, it's okay. But I believe that, or that's just my assumption. You can call it guessing. My assumption is that when you put an additional energy, when you put additional energy in this and you rearrange the plant and you move them, I do not believe that that movement is gonna do a significant thing. I do not believe that. Okay, before we come to the actual experiment, I would like to repeat what we include in the model. In our model, we include that our plants always require the same space in our total space. And what do I mean by this? Just imagine any object, your cell phone in your hand, put it upside down, it always requires the same volume in space. The formula we are going to apply is kilogram per cubic meters times joule or so times energy, because we need to include the energy because one system, the treatment system, we are going to move. So we need to consider the energy that we put into that system. So then let's go over and design an experiment. Okay, so it might surprise you that our experiment is relatively simple. Look, this is our three-layer conventional vertical farming system. This is our control. Okay, this is our treatment. So we say that each layer requires 100 watts for the light. (100 watts). So we have 1, 2, 3, 4, 5, 6, 7, 8, 24 plants. Of course, we pick seedlings that in the exact same condition, lamps, complete configuration is the same. The target is that that system here, we have to move this one. I'm not so much into that how fast and how often you have to move it, but if you do not move this, the plants are going to grow like this. But if you move that, the plants grow in a normal position, okay? But this here, it requires, that's just an assumption, but it requires, let's say, 15% more energy. And then we cultivate our lettuce seedlings with our 100 watt light intensity on our 3 areas for, let's say, 25 days. And the control will have a yield. Here we will have a yield, and here we will have a yield. And because everything except of the fact, the room that we use is the same, we just, we just have flipped. We have just flipped our shelf. We have just flipped it, and because everything except of the angle in what the plants are growing is the same, so it is very comparable, very comparable. Of course, also nutrition, everything has to be exactly the same. And then you can compare the yield from this one and to this one, and then you can put your yield into relation of our room, which is the same, yeah, and into the amount of energy used. Yeah, so you will have kilogram by cubic meters time kilowatt hours, or you can use joule if you want, whatever you want. And it is, I don't know what is going to come out. I don't know. it is what could be the possible outcome? Let's discuss that. Okay, what data will we get? We will get data for the yield. We will get data for, I mean, we have that at the start, we because our room, our space is the same, and energy. So the yield, let's say that one is higher. So yield control is lower than yield of the treatment. Then this one is the same. This is the same, but the energy, that one will probably, so the energy of control, it will be lower than the energy of the treatment. Um, so it is, if that yield is higher and you need more energy, it is possible that you have the same efficiency. Imagine you put in 10%. Let's say you have, is this red? Can I draw, please? Yes. Let's say you have plus 10% yield. Okay? And you require 10% more energy. Then the efficiency of both systems is the same. This is the same. But if you have here plus 20 and here you have plus 10, then the treatment clearly wins. But the other way around, if you have here plus 10 and here plus 20, that means that you have a higher yield with the treatment. However, you are losing efficiency. So, but what happens if I need a color that I have not used, that one. So you have here plus, I don't know, 0.5, okay? And here you have plus, let's say you definitely need more energy. You have plus 10. Then you have lost a lot of efficiency, you know, a lot. And this is what you need to find out. But the point is, you need to design the experiment in a way that you are using the exact same system in a different position, because then you are able to make to say something about the effect of the movement itself. And you see, it's relatively easy. Really, it is relatively easy. We have just taken the same system and we have flipped it, and you need some technical solution in order to move it up and down. That's all. I know you cannot build this at home, but you see the system from Dyson, for example, it is a lot more complicated to build, you know. Okay, so with that last slide, I would like to emphasize that it is in science always really necessary that you find a way to make things comparable. And as you can see, let's say you wanna find out whether these which of these systems has a higher Which one is better? Okay, and first you need to define what is better. Um, Better is, in my opinion, higher yield. And second is how you gonna find out which one has the higher yield. Let's say that one of these tubes from Dyson system has about the same size like this system, okay? And then you say, okay, we let it run with the same crop and then we compare it. That's not a bad idea, but when you consider that that one here maybe has 30% less space than that one, and when I say space, meanwhile you know what I'm talking about, um, then you're you know you're when you just compare the yield, you might be completely wrong. So you always need to find a way to make things comparable. And there are some um, both systems cover movement, okay? But with none of these systems you can really say that movement it helps or it doesn't help, because where's your control of something similar or something comparable that does not move? This is why I suggested in the experiment that we have the exact same system with the exact same space. One is moving, one is not moving. So the easiest way to find out whether moving is good or not, whether it helps or not, whether it leads to higher efficiency or not. Um, with that said, I would like to close here. If you have any thoughts, feel free to write them in the comments. Thank you for watching. Like the video, subscribe, and as I said, leave a comment if you want. Bye bye.